Okay, so our talk today is about sandboxes. I'm going to talk about industrial sandboxes. Why do we need them? I'm going to compare them to regular IT sandboxes. And we're going to talk why we need sandboxes, why we need another sandbox. There are so many out there. What we're doing differently, and we're going to show some examples. So why do we need a sandbox? So first of all, let's start by something simpler. Where are we getting the malware? And there are several sources. Some of them are public, such as sample pools. There are multiple free websites, VirusTotal. There are a lot of websites that give you an access to pools of samples, of malicious samples. There are a lot of malware forums, which means darknet forums, some crime Russian forums, forums that requires to have some reputation to get into them. And of course, honeypots. You can set up your own honeypot at home and get samples as much as you want. Everyone is getting infected all the time. So these were the public sources. There are also private sources. Private sources are coming from customers, from product deployments, from incident response. And when we're doing incident response, we're getting a lot of files, and we need to scan them rapidly and give answers quickly. And of course, there's private intelligence sharing between companies that are in the field. If we are taking all the samples from public sources, from private sources, there's a huge overload of samples, of a lot of malicious files, also not malicious, just regular files. But the thing is that you need some way to arrange them and get what's interesting to you, because there are a lot of files. There are regular Windows files, maybe some Linux files, maybe Android apps, and of course a lot of malware. Our clients also request all the time that we have them with malware investigations. They're getting infected all the time. Even IT environments get infected all the time. And the thing is, when you're dealing with large malware pools, with a lot of samples, you need somehow to automate it. Because even if you have a research team of, I don't know, 20, 30, 100 guys, they won't be able to manually analyze everything that there's on the web or anywhere. I mean, there are so many viruses out there, it's just not possible to do it manually. So besides that, there are a lot of malware there, it's also analyzing each sample takes time, because it might be obfuscated. It might be some other execution environments, such as VBS script, JavaScript, .NET applications, obfuscated .NET applications. I mean, if any one of you have tried reverse engineering something that's obfuscated in a script language, it's just hell. I mean, it takes so much time. Sometimes you don't even have all the samples. Maybe it's downloading something from the internet. Maybe it's dropping something, unpacking something from its resources. There are a lot of possibilities, and analyzing malware samples just takes time. And of course, there are known malware that you don't want to analyze because someone already did it before. You don't want to repeat the work. Okay, so when we're analyzing malware, what do you want to extract? Probably it's going to be what's it doing, what's its CNC servers, what files it's trying to pull from the internet, how it interacts with the system. And we can take whatever we're looking for and separate it into some groups. First, probably we want to see what's it doing from a file system perspective, from which files it's accessing, modifying, deleting, or just trying to open, which registry keys it's accessing. Does it open some network to some connection to CNC server, or does it inject itself into some process? So I'm sure you're familiar with sandboxing. There are a lot of sandboxes out there. Why do we need another one? And if we look at the sandboxes out there are free sandboxes, such as hybrid analysis, for example, or it's semi-free sandbox also, but there are also sandboxes where you can submit files and later pay on. There are appliances-based sandboxes when you can get a sandbox, put it into your lab, and analyze whatever you want, and open source sandboxes such as Cuckoo. So all the sandboxing, all the sandboxes doing probably usually the same stuff. They're looking for processes, they're looking for networks, for files. They're executing snort and YARA rules. But the problem with that is that what they're looking for is usually IT-oriented. They're looking for snort signatures of IT-oriented attacks or YARA signatures of IT-oriented attacks. They're looking for access to processes that, again, IT-oriented. And the thing is, if you'll take, for example, some malware that needs to interact with some OT components, and it gets into an IT sandbox, and it doesn't find these components, it probably won't be able to run. It probably won't be able to execute its cool features. And another thing, usually when you're using an IT sandbox, it executes for like 5-10 minutes, gives you the results, gives you a report, shutdowns, and that's it. So for us, it wasn't enough. We wanted something a little bit different, something that will give us some more data. And it says that we're looking for ICS-specific stuff. I'm going to show you in a second how do we do that. But again, we're trying to achieve the same thing. We're trying to shorten the time of the analysis for malware samples. And we're trying to not just analyze every malware, but firstly identify if it's OT-oriented, ICS-oriented, and then analyze it. Because, and then analyze it probably manually or something like that. It shouldn't be a full process. But the important thing is to eliminate the garbage, all the ransomware, or the bots, or all the crypto miners that are out there, and there are just millions right now. And of course, we're showing as a tool for analysts, not as a security measurement for your network. So I'm going to show you what you are looking for, and I'm going to do it by example. That means I'm going to show you some OT malware, what's its characteristics, and how we're planning to catch it. So if we take a look at Havex. Havex is operated by Dragonfly. It was around 2015, 2014. And when it gets to the machine, it tries to scan the network. It doesn't, the main feature of the scanning is scanning for OPC servers. That means they're trying, if somebody here I'm sure most of you tried interacting with OPC servers. The thing is, you need OPC DLLs installed on the system. You need some OPC client installed on the system. You need to create a COM object, and then you can only scan the network and interact with devices on the network that are OPC devices. So usually, normal IT sandboxes won't have the OPC DLLs installed on the system. I mean, they probably have full working system, but without these DLLs. And when you try to use this DLS, it won't be able, and probably the continue of the code, the other code that it does after that, won't be executed. So we solved it by, first of all, pre-installing OPC DLLs. Also, we're installing, it's not just for OPC. OPC is just an example. We're installing other libraries that might be used by OT malware. We monitor access to it, and we're not stopping there. Monitoring access to the OPCs is not enough. We want to see if it does something else after it finds the OPC servers. For example, I don't know, issue some comments to it or pull out some data. So for that, we simulated also OPC servers, active OPC servers in our fake network that malware can interact with them. Another example is the kill disk attacked in Ukraine. It looked for two processes, two specifically ICS-specific processes, and these are the commute.exe and the SEC service, both of them industrial-oriented. One of them sometimes used by some serial to Ethernet connector, and kill disk try to terminate them. So we're proposing to virtualize the existence of ICS processes on the sandbox. That means it's not just enough to monitor the access to it, because, for example, usually malware, when they're looking for some process, they're not going to write the exact name and exactly access to it and try to terminate it. Usually they will enum all the processes in the station and hash them in some way, and then compare the hashes to predefined hashes before. So we really need to virtualize them. We're virtualizing a lot of engineering stations, a lot of HMI workstations, I mean their processes, and their open ports. And of course, we're monitoring access to them. Another example is Industroyer, the data wiper part, not of Industroyer. We'll talk about other parts of Industroyer later. But data wiper part wipes specific files, and specific extensions. So again, we can virtualize these files, these extensions, see how many files that are IT-oriented and OT-oriented are being accessed. It means, for example, if it accesses only OT-oriented, it's probably not some kind of generic ransomware, but if it accesses all the IT-oriented files, it's probably just some ransomware. So again, we virtualize the files, we monitor access to them. Another example of Industroyer is OT-oriented network attributes, such as IEC-104. It communicates on this specific port to 404. And we're not just looking for access to them, we're also virtualizing the traffic. We want to see that it's not just random port scanning or just random access to this port. We want to see that it sends the traffic that is specific to this port. It means if it's talking IEC 104, we want to see that it sends this traffic and then alert that we've seen this traffic. Okay, so another thing I talked about that IT sandboxes are doing analysis only for 5 to 10 minutes. Back in 2016, we discovered a malware called Backdrop. Backdrop attacked in Ukraine. It was targeting industrial infrastructure. It was looking for the reconnaissance data. The first stage, it didn't have any ICS capability, but it had a lot of reconnaissance capabilities. And they were pulling out microphone recordings. They had really cool techniques of reflective DLL injections, and it was multiple stage. And the important thing here is that it was operated manually. That means there was an app operator behind it, and the operator approved which stations are going to be, which workstations are going to be infected. Not just everyone. It's not something automatic that infects everything. So we knew that's a sophisticated attacker. It was some government in that area. And we decided to set up an environment that will fit the profile of the computer that is being attacked. And that profile is an Ukrainian computer. So we set up a Ukrainian computer, Ukrainian keyboard, computer name, dropped Ukrainian files there, made sure it goes through Ukraine. We gave it an Ukrainian IP. And we put a lot of analysis tools there, Wireshark and stuff like that. Hid them, changed their names, made sure nothing is detected. That's the infrastructure. We had a computer, a physical computer we set up in our laboratory with a VPN connected to the internet through our network, and we monitored everything. And after a day or two, suddenly we saw some traffic. I mean, there was traffic before. It was communicating to the CNC server. It was also always getting a page not found. But after 1 or 2 days, after it collected the data, the computer name, the username, it suddenly started talking with its protocol. That means we got the modules, we got the inner modules, and we got the main malware. We didn't know everything I showed you before. We didn't know with the dropper modules. We needed the main modules to uncover everything, and waiting for the operator to approve us because our profile fit his victim gave us the other modules. So what we want to do in our sandbox is design a sandbox that's going to operate for days, for even a week, and design profiles that fit the victims. That means if it's something targeting the US, a computer from the US, if it's a Ukrainian computer, give him a Ukrainian profile, and of course, give all the IPs and everything so it will look legit. And that's something that regular IT sandboxes doesn't do. Of course, we have some other future improvements we're going to do, such as models that are interacting with GUIs, with graphical user interfaces. That means if there's some installation program. We have a lot of research into symbolic execution, and we're planning to integrate it with our sandbox. That means if something requires an input to the file, we're going to symbolically generate it. And if it requires other models, we're going to look in some sample pools. So these are just future stuff. And now I'm going to show you a demo. The demo is screenshots. So be with me for a second. So that's a sandbox. That's the login screen. We can upload files here. And these are the analysis reports. We submitted some files to here. So this is the working sandbox. And we can see that we have there a column of OT characteristics. That means how many alerts that are relevant to OT it has detected. So if we'll click, for example, we'll take the Havex malware. I don't know if you can see it from here, but there's an access to COM object, and it says it's trying to access to OPC server list, which is the interface that Havex used for scanning. There are some other alerts like dropped files or which files it has accessed, some regular other sandbox stuff that you probably want to know just to feel what the malware does, not just the OT characteristics. And from here, once we get these alerts, once we get this data, we can further continue and reverse engineer it manually. So it's a trigger for manual reverse engineering stuff. Also can download the pickup. And if we open the pickup, you can see here real DCRPC communication. It communicated with one of our virtual servers. We can also analyze the traffic. If we look at a sample from Industroyer, the 104, we can see here that it tries to access to the specific OT port, and it tries to close a process that's related to it's related to this protocol, because Industroyer not just scanned using this specific protocol, it's also closed the original services that are using the protocol. And if we download the pickup, we can see here real 104 traffic, again, communicating with our virtual server, and we can analyze the commands it's sending. And of course, we can detect it, and then we can analyze it manually. It's also assisting us to analyze. We don't have to set up the whole environment. The environment is already here. We're going to open it to a beta test soon. So if you want an access, you want to try the tool, just contact me. We're going to give beta keys. And that's the presentation. We have a book signing at the Cabana session. And that's it.
Okay, I'm Jason Holcomb with Revolutionary Security. I'm going to help field questions here for David. Do we have any questions? Okay, surely somebody has a question. Okay, if not, I'm going to ask one or make an observation. So I've noticed in doing some like tabletop exercises in the past where I'm working with an IT SOC and I put in front of them an OT challenge, I've noticed that sometimes they're a little overconfident on their malware analysis skills, because they'll come back and say, we would have been able to do the analysis for this piece of malware in some really short period of time. And I point out to them that no, it very likely could have taken a lot longer to get to the industrial control system piece of that. So can you speak to how, I know the presentation really focused in on this, but more examples of how that saves an analyst time to have that kind of sandbox that's focused for OT?
So yeah, great question. First of all, we are doing reverse engineering for OT malware for years already. We've seen them before. We've seen them during the military service. And usually the hard part is understanding what's related to OT and what's just IT stuff, regular IT stuff, like regular injections and regular scannings. And the sandbox gives the perfect tool to understand what might be OT related and start digging from there. It means if it sees some port that's related to ICS software, you can say, okay, just instead of analyzing the whole malware, I'm going to find where the socket is being opened, where it does the connect function, go to and find the exact port and start analyzing from there. Or not. Say this, okay, this is the OT stuff. I'll give it to someone that knows OT stuff, and I'll analyze everything else. Does it answer your question?
Yeah, it does. And I think that's part of the challenge. And right now, in a lot of environments, the analyst doesn't have the OT level insight, and the person that would understand the OT side doesn't really understand malware reverse engineering. And so I think that helps make a good case for for why that kind of sandbox would make sense. Okay. Any other questions for David?